So the brave of heart come to talk about the extension for the bromination discussion. I'm going to have a movie in my usual PowerPoints, and then right after that is a separate movie that I made moving the molecular models around. But we'll start off with this one with cis-butene. I hope you don't mind me calling it cis. I should call it Z-butene, but really cis just sounds better because I'm an old person, and that's what we always used to say. And in the same way that I've given you those trivial group names, things like tert-butyl and so on, you need to be bilingual. You need to know the proper way, if I may say it, the IUPAC way of saying it, or you need to know the way that most people say it. And people are going to talk about this as cis-butene or cis-2-butene rather than the whole Z thing. Anyway, the 2 tells me we start at carbon 2, carbon 1, carbon 2, carbon 3, carbon 4, while carbon 1 and 4 are, of course, integral parts of that bute chain. Here we're interested in the carbon 2, carbon 3, double bond, carbon 1, carbon 4 are just methyl groups. Now let's react that up in the same way to make 2,3-dibromobutane. Well, 2,3-dibromobutane is a fun molecule because if you look at both carbon 2 and carbon 3, they are chiral. Carbon 2's got a hydrogen, a bromine, a methyl group, and then the rest of the molecule here. Carbon 3's got a bromine, a methyl, a hydrogen, and the rest of the molecule there. Now, there's 2 possibilities for carbon 2, R or S. There's 2 possibilities for carbon 3, R or S. In other words, there's the possibility of 4 geometric isomers of 2,3-dibromobutane. Let's draw those and think about it. Now, as I've talked about when we've done some of these workshops, when you're asked to draw a molecule, you have all kinds of freedom in how you do it. Now, what I've done just to make it a little bit easier here is I've said, well, I'm going to draw, first of all, these staggered conformations. Okay, so that makes it a little bit easy to visualize some of these things. And in each case, I'm going to draw the hydrogen back. If you draw the hydrogen back, it makes it much easier to assign the absolute configuration, to say which is R and which is S. So hydrogen back. So if we look at carbon 2 hydrogen back, it's got this carbon 3 there, which I'm always going to draw in the plane of the paper. And then I can either put bromine at the top and methyl at the bottom, or methyl at the top and bromine at the bottom. Okay, so that's the 2 possible arrangements around carbon 2. Around carbon 3, same idea, hydrogen going back. I can either have methyl at the top and bromine at the bottom, or bromine at the top and methyl at the bottom. So now let's assign them. Okay, priority, bromine's always 1. The other bits, 2, methyl is always 3. So here I go, bromine, rest of it, methyl, that makes that R. Go over here, hydrogen back, bromine, rest, methyl, still going clockwise, so carbon 3 is also R. Move to this one, hydrogen back, bromine, rest of it, methyl, 1, 2, 3, counterclockwise, anti-clockwise, so carbon 2 is S. And then this one here, hydrogen back, bromine, rest, methyl, 1, 2, 3, also S. So there's the RR and the SS. And these, if I'd drawn them in a different way, you would actually see are enantiomers, because of course R when reflected becomes S, R when reflected becomes S. Now going down to these, we can do it a lot more quickly. I've already said when you've got the methyl at the top and the bromine at the bottom, carbon 2 is S. Over here, carbon 3, I've got the methyl at the top, bromine at the bottom, so that's just like that one, so that's R. And then here, flipped around, bromine at the top, CH3 at the bottom for carbon 2, that was the R version. And around carbon 3, bromine at the top, methyl at the bottom, bromine top, methyl at the bottom, that's the S. So again, these 2, although I'm going to say this in inverted commas for reasons that we'll talk about in another extension video, you can also say that these are enantiomers. So anyway, 4 possible products of the bromination of cis-butene. So there we are, drawing it flat. There's the bromine coming in, usual old silliness. There's the bromonium ion, okay? And now we've got our bromide. And that bromide is going to attack from the bottom. It can attack at carbon 2, or it can attack at carbon 3. Here we are coming in, and let's first of all have it attack at carbon 2. Now picture what's going to happen when it attacks at carbon 2. This bond's going to break, which means carbon 3 is the one that's attached to this bromine, and carbon 3's bromine therefore is on top, and carbon 2's bromine is on the bottom. There we are, carbon 3 bromine on top, carbon 2 bromine on the bottom. Obviously, as the bromine comes in from the bottom on carbon 2, it's pushing the methyl and the hydrogen up. And of course, the bromine on carbon 3 was going up, which means the hydrogen and the methyl coming down. Signing the configurations. Here's the carbon, hydrogen back, 1, 2, 3, S. Here, hydrogen back, 1, 2, 3, also S. So when the bromine attacks from the bottom of carbon 2, we get the SS. Now let's have it attacking from the bottom of carbon 3. When it does that, now carbon 3 is not going to be bonded to the top bromine anymore, so the top bromine bonds now to carbon 2. So carbon 2 has the bromine up, carbon 3 has the bromine from the bottom. You think, what's the difference? Well, go and assign them. Hydrogen back, bromine, rest of the molecule methyl, 1, 2, 3, so that's R. And hydrogen back, 1, 2, 3, also R. So cis-but-2-ene, when we brominate it, we make SS, it would actually be 2s3s dibromobutane and 2r3r dibromobutane. We do not make the SR or the RS possibilities. If I want to have the SR or the RS, then I wouldn't start with cis-but-2-ene, I would start with trans-but-2-ene. And that's a puzzle we might do as part of a workshop, or you might do it yourself and just demonstrate for yourself that when I use trans-but-2-ene, I will make these possibilities with the bottom attack. I will not make RR or SS.